Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the motion under uniform acceleration. Let us begin. So far, we covered different parts, that is, such as some of the topics, such as projectile motion, and we calculated what is the equation of projectile motion, and from that equation of the trajectory, time of flight, range, and maximum height. The projectile which reaches the maximum height are calculated. Here we are going to study the uniform acceleration or motion, so related to that, and also going to solve some few problems related to this topic. Before going to start uniform motion or uniform under uniform acceleration, motion under uniform acceleration, we need certain terms, certain definitions to understand the motion under uniform acceleration. Now let us begin. That is the speed. What is the speed? What is velocity? What is uniform acceleration? What is variable acceleration, etc. Now let us begin with the speed. The speed is defined as its rate of change of displacement with respect to its surroundings. So that means the rate of change of displacement with respect to surroundings means time, function of time. The speed of the body, is a scalar quantity because it is mentioned in respect of its direction. That's why it is a scalar quantity. Now, what is the vector? What is the velocity? The velocity is a vector quantity because it is always expressed in particular direction. And what is the velocity? Velocity means is defined as the velocity is the rate of change of displacement with respect to time. Rate of change of displacement with respect to time is known as the velocity. The unit for velocity is meter per second or centimeter per second also, but generally we follows unit of velocity is by meter per second. Is the rate of change of displacement with respect to its surroundings. With respect to its surroundings is known as the velocity. Now velocity is velocity can be always exposed in particular direction. That's why it is a vector quantity. Now the term, very important term, is the acceleration. What is the acceleration? Acceleration is defined as the rate of change of velocity with respect to its surroundings, or is the rate of change of its velocity is known as the acceleration. So the acceleration, the unit for acceleration is meter per square second. And there are two types of acceleration. Here the term, when the acceleration is positive, that means the velocity of the body increases with the time. And the acceleration is negative, that means it decreases with the time. So the negative acceleration is known as retardation. Okay, and the term acceleration is used to denote the rate at which the velocity is changing. That's why the unit is that meter per second per second. The rate of the velocity is the v and the t is the time. The change of velocity, the term velocity changing here with respect to time is known as change of velocity. The rate of change of the velocity is known as acceleration. That means the physical significance is that at what time, along with the time, how the velocity is getting changed. That is known as acceleration. Okay. So the acceleration can be uniform or variable acceleration. The term is there. Next is uniform acceleration. What is the uniform acceleration? If body moves in such a way that the velocity changes in equal magnitudes with equal intervals of time. Change of velocity in equal magnitudes and in equal intervals of time it is said to be, that is known as uniform acceleration. What is the variable acceleration? The variable acceleration means velocity changes in unequal magnitudes, okay, in an equal intervals of time. That is known as a variable acceleration. Unequal magnitudes, velocity changes in unequal magnitudes in equal intervals of time. Okay, here, whereas uniform acceleration, velocity changes in equal magnitudes in equal intervals of time. Okay, that is known as uniform acceleration. Here the variable is that velocity changes in unequal magnitudes in equal intervals of time. Okay, that is known as variable acceleration. Now we are going to derive the expressions under motion with uniform acceleration. The equations of motion with under uniform acceleration, such as v equal to u plus at. Another equation is s equal to ut plus of at square, and the third one is v square equal to u square plus 2as. These three equations are going to be derived now based on the terms where v is the final velocity and u for initial velocity, a for acceleration, and t for time. And there is one more variable, that is s. S is the term, s is known as the displacement. Now by using here this terminology, we are going to calculate that derive the equations of motion. And before that, s is the distance traversed. What is the distance? It is the total distance moved by body. So mathematically, provided if we know the terms velocity and time, then the distance traversed s equal to v times t. That's why unit for displacement, distance traversed, is meters. How? S equal to v times t. What is the unit for v? Meter per second. What is the time? Second. Second get cancelled. It is in meters. Here, motion and our uniform acceleration. Now coming to the motion, what are the equations of motion? We are going to calculate here. We are going to derive the expressions. Now, here in this diagram where OPX, from the body moves from O to X, the P is the position. So where P is the position after t seconds, let U be the initial velocity, V be the final velocity, S is the distance traveled in seconds, where A is the uniform positive acceleration. Uniform negative acceleration is nothing but a retardation, and the time t taken by the particle to change its velocity from u to v, that means from initial velocity to final velocity, the time is known as the time. That is the unit for time is in seconds, whereas unit for initial velocity in meter per second, and unit for final velocity is also in meter per second, whereas the unit for acceleration is meter per second square. Alright, here we are considering positive acceleration. The coming under negative acceleration, that means positive acceleration means the velocity increases. Alright, now the particle, the p is the position of the particle, it moves. The body, let p be the position after t seconds. Here the body moves from O to X. Alright, now here let us begin with the time t is the body, or the particle moves from initial to final. That total time is known as the it is in seconds. It is not in minutes or in hours. Now here the velocity of the particle is increasing steadily from the initial velocity u to final velocity v at the rate of acceleration small a. Therefore, the total increase in velocity, that equal to v equal to total increase in velocity equal to a times t. Now the final total increasing velocity means u and u to v. U to v equal to, what is u to v? The total increasing velocity is a times t. Now what about final velocity? The final velocity equal to initial velocity times velocity, the total increase in velocity, that is a times t. That's why this is the equation, one of the equation of motion. Final velocity equal to initial velocity, the sum of initial velocity plus the sum of initial velocity and the total increase in velocity at. V equal to u plus at, where v is the, again, final velocity, unit for final velocity in meter per second, and u for initial velocity, it is also unit for initial velocity in meter per second, where a for acceleration, unit for acceleration is meter per square second, and t for time, it is unit for time is in seconds. Now coming to average velocity, the average velocity equal to initial velocity plus final velocity by 2. This is the average velocity. Now the distance traveled by the particle s equal to average velocity times time. So u plus v by 2 times t, where substitute here in this equation u plus v by 2 times time, where what is the v equal to u plus at. Substitute in this, we plug this final velocity in this equation, then u plus, where v for u plus at by 2 times time, then what is the equation? If you simplify it, u plus u, that is 2u plus at, 2u plus at by 2 times t. Now 2u times, if we simplify it, 2u by 2 plus at by 2 times t. Next, simplified t, product of the t goes inside the bracket, ut plus of a times t square. So this is the final. Now final equal, that is s equal to u times t plus of at square. This s equal to ut plus of a, what is the s for? Distance traveled by the particle, and u for initial velocity, t for time, u for uniform positive acceleration. Now s equal to ut plus of at square. This is another equation of motion when the body moves under uniform acceleration. Now coming to the next expression, now v equal to u plus at, we know that from that v equal to u plus at, v equal to u plus at, from this equation what is the t equal to v minus u by a. This is another. Now we know that the distance traveled s equal to average velocity times the time, that is vu plus v by 2. What is the time? T equal to v minus u by a. Substitute over here. Then what will happen here? That equation is transformed into another term, that is v square minus u square by 2a. Whereas if it is simplified, v square minus u square equal to 2as, and whereas v square final velocity square equal to initial velocity square plus 2as. This is the final. Okay, there are three equations. One is v equal to u plus at, another one s equal to ut plus of at square, and final one v square equal to u square plus 2as. These three equations are very, very important to solve the problems. Now let us apply to solve the problems. Let us begin here. The problem number 1. A car starting from rest is accelerated at the rate of 0.4 meter per square second. Find the distance covered by the car in 20 seconds. Is a square second. Okay. Now we have to find out, a car is starting from rest. That means what? Initial velocity equal to 0. And at the rate of 0.4 meter per square second, based on this unit, accelerated, this is what acceleration. Okay. And find the distance covered by the car in 20 seconds. The total time is the t equal to 20 seconds. And one more thing, the distance, find the distance covered by the car. We want the distance s. Now s, a, and the time, and u. This s and a, distance from yes, u, a, and t. These are the four things. What is the equation of motion? The formula is s equal to ut plus of at square. By using this equation, we can solve the distance covered by the car in 20 seconds. Now, what is that? Yeah, now plug these values into this derived expression. We'll get it as 80 meters. Yes, s equal to ut times of at square. What is the u for? Initial velocity is 0, 0 times t. 0 times 20 seconds, substitute over here, plus of a, 0.4, where a is the acceleration, 0.4 times t, 20 whole square. Now 0 ut plus of at square. This 0 times t, this becomes 0 of at square, that is 2 times this 0.2, that is 400, 400 times 0.2, that is 80 meters. So a car starting from rest with an acceleration of 0.4 meter per square second, and in 20 seconds the car moves. The distance traveled by the car is 80 meters. So these are very real application problems, so important. That's why it is related to dynamics or dynamics. Now another one, let us solve and begin with another problem. A train traveling at 20 kilometers, 20 kmph, kilometer per hour, is accelerated at the rate of 0.4 meter per square second. Now again, what is the distance traveled by the train in 12 seconds? Now a train traveling at 27 kmph, we want a distance traveling, that is the initial velocity u equal to 27 km per hour. It should be converted into meter per second, that is 7.5 meter per second. Accelerated at the rate of 0.5 meter per square second. What is the acceleration? That is a equal to 0.5 meter per square second. And the distance traveled by the train in 12 seconds, the time was given here. So based on this, we need distance traveled by the train. Before problem, distance traveled by the car. Now here it is distance traveled by the train. So based on this data, the formula is going to apply S equal to ut plus of at square. You may say that what about another formula, v square equal to u square plus 2as. Here also s is there, but what about the time consideration is not there. Now we are going to apply, whereas s equal to ut plus of at square. Where is the u for initial velocity, t for time, a for acceleration, and also here substitute over here those values in the expression of s equal to ut plus of at square, where u for initial velocity, that initial velocity that is converted from 27 km per hour into meter per second, the obtained value is 7.5 meter per second. Now substitute here 7.5 meter per second, the time t is the 12 seconds. 7.5 times 12 plus of a for acceleration, that is the positive acceleration, that is 0.5, whereas the t for 12, that is a 12 square. 7.5 times 12 plus of a, 0.5 times 12 whole square, then the obtained value is 90 plus 36, that is 126 meters. The train traveled with the speed of 27 km per hour and acceleration of 0.5 meter per square second for a time of 12 seconds. The distance traveled by the train is 126 meters. Okay, next. If you take it next problem, a motor car is in 10 seconds and cover 30 meters. A motor car in 10 seconds covers in 30 meters. And 12 seconds to cover 42 meters. Find the uniform acceleration of the car and its velocity at the end of, at the end of the time, that is the 12 seconds, at the end of 42 meters traveling. Now we are going to hear when the t equal to 10 seconds, the given data s equal to 30 meters and t equal to 12 seconds, s equal to 42 meters. Now we are going to find out here at the end of 15 seconds we have to make it. This is the 15 seconds. Now here 10 seconds 30 meters, 12 seconds 42 meters. Now we need acceleration of the car and its velocity at the end of 15 seconds we need. Now based on the solution here, let us begin the solution. The data given t equal to 10 seconds, s equal to 30 meters, and t equal to 12 seconds and s equal to 42 meters. Now the uniform acceleration we need, u for initial velocity of the car, a for a uniform acceleration, and we know that s equal to ut plus of at square, u times t, 10 plus of at square. From this one equation, 30 equal to 10 u times 50 times a. And multiplying the above by 6, what will happen here? 180 equal to 60u plus 300a. Now distance traveled by the car in 12 seconds. Again substitute s equal to ut plus of at square, that s is 42 meters, that is u plus u times 12, that equal of a 12 square, then 12u plus 72a. That's 200 by 210 by my equation for simplification. 210 equal to 60u plus 360a. From this here, by subtracting the equation, by solving, this is equation number 2 and it is equation number 1. We know the two equations and two unknowns u and a can be calculated. So from those two equations, that is 30 equal to 60a, where a for that is 0.5 meter per square second. That is the uniform acceleration. Now velocity at the end of 15 seconds we need. At the end of 15 seconds, we know that the equation s equal to u t plus of a t square, where a for here, then the equation that is 60u plus 150, from that u equal to 0.5 meter per second. We know the final velocity v equal to u plus at. What is the u for? 0.5 meter per second, and a for acceleration 0.5, and t for time, that is 15 seconds. So at the end of the velocity, final velocity after 15 seconds, that is 8 meter per second. Okay, the next problem here, let us begin with here. A burglar's car had a start with an acceleration of 2 meters per square second. A police vigilant party came after 5 seconds and continued to chase the burglar's car with a uniform velocity of 20 meters per second. Find the time taken in which the police van will overtake the burglar's car. Find the time taken, how much time in which. So the given data is that acceleration is 2 meters per square second and the time t equal to 5 seconds, and uniform velocity is 20 meters per second. Okay, and we need the time taken in which the police van will overtake the burglar's car. Okay. This is the real application problem here. The police people here, what happened? Police vigilant. The vigilant people always wants to chase the poor people. I mean, not always. This is highly useful for calculation. At what time, at what velocity he has to travel. Not only time. It is asked here. It is only time taken. But generally, what velocity we have to overtake the robbers or some. Okay. Those cars. So let us begin. Letter T is the time taken by the police party to overtake the burglar's car after reaching the spot. That's what this T is the time. Now first of all, consider the motion of the burglar's car. That is, you are going to consider the motion. Now in this case, the initial velocity is 0 and the acceleration is 2 meters per square second. And the time taken by burglar's car to travel the distance is t1 equal to t plus 5 seconds. Okay, and the distance traveled by the burglar's car s equal to ut plus of at square. Substitute u t, what is u for u, and also acceleration here. The initial velocity is 0 times t 0 of times a. Acceleration is 2 meters per square second, and the time t is t plus 5, that is the whole square. Now here for simplification, after simplifying, s equal to t plus 5 whole square. Now consider the motion of the police party. Before that we consider the burglar's car. Now police vigilant people party, in this case the uniform velocity is given here, that is 20 meters per second. Now the distance traveled by the police vigilant, that is s equal to v times t, that velocity, that is 20 times t. Now for the police party to overtake the burglar's car, the two distances are equal. Now make it equation 1 equal to equation 2. The equation 1 equal to equation 2, if you make it, t plus 5 whole square equal to 20 times t. If you simplify it, what is t plus 5 whole square? That is t square plus 25 plus 10t, that equal to 20 times t. So what will happen here? T square plus 25 minus 10t equal to 0. Now it is nothing but a minus b whole square, a square plus b square minus 2ab. That is t minus 5 whole square equal to 0. That is t minus 5 equal to 0. That is t equal to 5 seconds. Okay, t equal to 5 seconds. This is the problem here. At what time the police people are overtaking? Okay, the police people are overtaking. The time in which the police van will overtake the burglar's car with this given data, the acceleration of 2 meters per square second, the burglar's car is moving, and a police after 5 seconds, these people are having the velocity. Acceleration is burglar's car. Here the velocity is 2 meters per second for police vigilant party. Now how much time to overtake for overtaking the burglar's car? That is 5 seconds it took with the velocity. Okay, 5 seconds that took to overtake the burglar's car. Okay, next problem is that is related to the train. A train is uniformly accelerated and passes successive kilometer stones with the velocity of 18 km per hour and 36 km per hour respectively. Calculate the velocity when it passes the third kilometer stone. What is the velocity? Now also find the time taken for each of these two intervals of 1 kilometer. Okay, now let us begin. First of all, consider the motion of the train between the first and second kilometer stone. There are three stones are there. First kilometer stone. Okay, first there are three stones. First kilometer, second kilometer, and third. We need the third kilometer stone. What is that velocity we have to calculate to overtake or to pass this third kilometer stone? Now in this case, distance s equal to, what is the distance? That is 1 kilometer, each kilometer, yes, successive kilometer stones. Passes successive kilometer stones, first kilometer stone, second kilometer, yeah. That is 1 kilometer equal to 1000 meters. Initial velocity u equal to 18 km per hour converted into meter per second, that is 5 meter per second. And final velocity, that is 36 kmph converted into meter per second, that is 10 meter per second. Okay. Let us begin. Velocity with which the train passes the third kilometer stone. That is final, that is v square equal to, where v is the velocity at which the train passes the third kilometer and a is the uniform acceleration. We know the derived expression, the third equation of motion, v square equal to u square plus 2as. Where the v is here 10 and u equal to 5 plus 2 times a, that is s equal to 1000 meters. If you plug those values of v, u and s in this equation, after plugging the outer acceleration is the unknown, this is to be calculated, that is a equal to the calculated values, that is 0.0375 meters per square second. Now let us hear one more thing. We are going to consider the motion of the train between the second and third kilometer stones. Now we are considering. For that, let us begin. We have to, what is the final velocity we need? The velocity with which overtakes the third kilometer stone. Then in this case, the distance s is again 1 kilometer, that is 1000 meters. Initial velocity u equal to 36 kmph, kilometer per hour, converted into meter per second, that is 10 meter per second. The derived expression for this here is that v square equal to u square plus 2as. What is the v for final velocity, u for initial velocity? By plugging these s and u in this to this equation, then what will happen here? We know the acceleration, that is 0.0375, where s for, that is 1000. If you substitute here, v equal to u square plus 2as, u for 10, a for 0.0375 and s for 1000. That is v square equal to u square plus 2 times as, that is 175. Yeah, that is equal to v square. V is the 175. Now what to be calculated here? No. Here 175. That is final. V square equal to u square plus 2as. No. Now what will happen here? That is 13.2 meter per second. That is 47.5 kilometer per hour. Okay. Next, the second objective is the time taken for each of the two intervals of 1 kilometer. What is the time taken for each of the two intervals of 1 kilometer? Now the time taken, T1 is the time taken by the train to travel the first 1 kilometer, and T2 is the time taken by the train to travel for the second kilometer. That is T1 and T2. Now the velocity of train after passing the first kilometer, that is in T1 and in T1 seconds, the velocity of the train after passing the first kilometer, that is in T1 seconds, that is V1 is the velocity. that v equal to u plus at1, v1 equal to u1 plus at1. From that, what is the v1 is 10 equal to u plus at1. What is the u? 5 plus ta 0.0375 and t1. From that, t1 equal to 133.3 seconds. Now similarly, for second kilometer stone, that is v2 equal to u2 plus at2. What is the u2 is? v2 is 13.2, whereas u2 is u plus, that u2 is 10 and a is 0.0375 and t2 is the time for second kilometer stone. That is the t2 is calculated as 85.3 seconds. Okay. This problem is very important here. The third problem is a very important model for examination point of view, and also to understand the concepts of the uniform motion under uniform acceleration. Okay, here in this problem we applied, there are two types of equations of motion. One is v square equal to u square plus 2as, and another one is v equal to u plus at. These two things we use here, we applied, that v square equal to u square plus 2as, another one is v equal to u plus at. Okay, and also one more thing is that here calculate, there are how many objectives are there. Calculate the velocity when it passes the third kilometer stone, and also find the time taken for each these two intervals of 1 kilometer. There are three objectives. One objective is the velocity when it passes the third kilometer stone. The second objective is that what is the time t1 for first kilometer stone, and the time t2 for second kilometer stone. There are three objectives are there to be calculated. So we already calculated by using two equations of motion, that is first and third one. That is, the first one is v equal to u plus at, and the third one is v square equal to u square plus 2as. Okay, these two equations of motion were used and calculated these three objectives, that is the final velocity and also t1 and t2. Okay, let me summarize. What are the things we have studied? First, we learned the terms, what is the speed, and the second term, velocity, and the third term is acceleration, and the fourth term is variable acceleration, uniform acceleration, and the fifth term is variable acceleration. Final sixth term is the distance traversed. These are the important terms. By using these terms, after understanding these terms, what we have done is that we derived the equations of motion. The equations of motion under uniform acceleration. The equation of motion under uniform acceleration, that is, the first equation is v equal to u plus at. The second equation is s equal to u times t plus of a t square. And third equation is v square equal to u square plus 2 times as. These three equations were derived here. And what is the v for final velocity, u for initial velocity, a for acceleration, t for time, where s for distance traveled by the body. By using these three equations, we applied these equations and solved problems to understand, and also how to apply these equations. while solving the problem, we have to observe very clearly the acceleration is uniform or not, and the bodies are moving, the particle is moving linear or not, it is moving horizontal path or not. When the body moves upward direction, when the particle moves upward direction, these equations of motions will be transformed. The acceleration, the place of acceleration, that is the positive acceleration, will be converted, is converted or it is transformed into the acceleration due to gravity. The gravitation is transformed into a gravitational acceleration. If the body is thrown upwards, vertically upward direction, or throwing downward direction, this acceleration becomes gravitational acceleration. Alright? Now, by considering the gravitational acceleration, for a gravitational acceleration, what are the equations of motion? Yes. And how to solve by using gravitational acceleration, how to apply this gravitational acceleration equations of motion under gravity, that is going to be solved in the next session. Now, these are the references were followed, 1, 2, 3, 4, such as R.S. Kurmi, Irving H. James, Hebler, and Beeren Johnston. We took as a reference and explained those concepts in this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.